Hey folks, welcome back. Today we're going to deal with conditional statements. This is going to be the first time in our code we're going to be able to make a decision and have the code do one thing or another based on a condition, which a type of condition would be a Boolean. So let's talk about this in the real world. So every day we make decisions all the time. Should I go to class today? This is a yes-no decision. Either yes, I'm going to go, or no, I'm not going to go. Should I stay home, take a nap? Likewise, yes, no. What should I wear? Well, that one's going to be a bit more complicated because you might have many choices. It's not yes or no. It's kind of a multiple choice question. And likewise, what I should have for lunch, that's kind of more of a multiple choice question. So different types of decisions that you make are different data types effectively. In general, most of the time in computer terms, we're going to be dealing with Booleans as our data type. So let's get into this real quick. So here's an example of a flowchart, and we've looked at flowcharts before, and they're useful for a couple of different reasons. But in this particular case, what we're going to do is we're going to talk about the decision-making tree. So let's assume that you start off and you walk into a room and the room is dark, and you're trying to figure out why it's dark. So this flowchart will step you through the individual steps. So the first thing we're going to do is we're going to check and see, is the switch on? So we walk over to the light switch, we figure out where that is, and we look at it and we decide, is it on? If it is on and the room is still dark, then there's something going on. If it's not on, well, then there's an easy solution. So if the light switch is off, we follow the path over here and we're just going to turn on the light switch. And now we check to see, did that actually make the room bright? If the answer is yes, we're done. Great, we have successfully turned on the lights. If the answer is no, then we follow back up to the top again, and we are back at the original decision point. Is the switch on? So maybe the problem here is we're looking at the wrong switch, maybe there's multiple switches in the room, or if the switch is on, then maybe it's something else. Okay, so once we have decided that the light switch is on, and the lights are still not on in the room, then we're moving over to this side of the decision tree. So our next question is, does the room have more than one light fixture? And that's an important decision, because if there's only one light fixture, there's only one bulb in the room, and the light switch is on, then perhaps we're going down this path where it's a blown bulb, and the bulb needs to be replaced. But if there's more than one fixture, then we would think it's unlikely that all the bulbs blew simultaneously. So then maybe we're looking at, is the power out, in which case we might need to call the power company. And if it's none of those, then I don't know, like, the light's not on, we turned on the switch, the power is on, there's no blown bulb, why are the lights not coming on? I don't know, something is wrong with the control system or something, who knows? But at that point, just give up and go find another room, right? So the point of this chart is, there's a lot of decisions. Each one of these diamond-shaped boxes is a decision point, and depending on whether you get a yes or a no out of each of these decisions, you're going in one path or another. Or to phrase it differently, each one of the things that I circled is a Boolean, and if it is true, you're going to do one thing. If it's false, you're going to do something else. And that is really how this all works. We're using Booleans to make decisions as to which way we want to go with things. All right, so let's move on. The next thing that might come up is, how complex of a question is it that we are trying to ask? So in that flowchart that we just looked at, the simplest case was, the light switch was off, we turned it on. That's really simple. Is the switch on or not is a yes-no question. But you can also run into things where it's more complex. So for example, the simple one might be, if it's raining outside, you should bring an umbrella to class. If it's raining, bring umbrella. If it's not raining, well, then you don't have to bring an umbrella. So that's a simple yes-no question. A more complex question might be, if it's raining and you need to go to class, then go get the umbrella. If it's hot and you have to go to class, then put on shorts. Otherwise, stay in bed. And so there's a lot going on there. You're checking a bunch of different things to make your decision. And so often in the real world, things are more complex than a yes-no, but in computing terms, we're going to have to break them down into yes-no decisions. And you can always do that. All right. So a conditional statement is what's being used to determine if we're going to do something or not. Conditional statements are always going to be based on a Boolean. And in order for it to be based on a Boolean, we're going to use some of the stuff that we talked about in the last class. We had the relational and we had the logical operators. And so here's an example that you might deal with. If we have a variable x that is an integer, let's say, we might want to see if x is greater than 3. And so if x is greater than 3 and y is less than 4 and z is equal to the character a, then maybe we're going to do something, and otherwise maybe we're not. And so these would be what you would use inside of your if statements as the Boolean part. All right, and the final thought here is the flow of control. When we started all of this, we began with main. So there was the main method, which was the public static void main, and then we said we're going to execute each statement underneath that all the way down until we reach the closing curly brace. And that's still true. The only thing that's different now is that some of those statements may cause us to skip other statements, and that's what an if statement is going to do. We will only execute certain statements if the Boolean was true. All right, so that gives us a flow of control that looks like this. You're going to have the condition that you're going to evaluate, and that condition is going to be a Boolean. If the condition evaluation comes out to be true, then you're going to go down and you're going to do the set of statements that it tells you to do. If it's false, you're just going to skip over the statements and move on to the statements below in the rest of the code. And we're going to see what that looks like in actual code next. All right, so here's an example of some code. We have a main method, and what we're doing here is we're starting off with, we're creating the scanner object, and this is just the two statements that we said in the read section that you pretty much just need to memorize. This creates a scanner for us. All right, so the code begins with what is your name being printed on the screen. So that's going to make the words what is your name appear on the screen. And then we're doing a myscan.next line, which is going to cause the computer to stop and wait for the user to type an answer in. Whatever they type in is going to get stored in a variable called name, which is of type string. All right, then we're using an if statement. This is our first time seeing an if statement. So we're saying if the name is equal to Sally, then go ahead and do this print statement. All right, so let's circle the if statement again, and let's talk about the flow of control here. So we started off and we did the first line, then we did the second line, then we did the third line. When we get to this fourth line, which is that if statement, it's going to check to see if that is true. If it is true, it's going to move on to line 5. But if it's not true, it's going to skip all the way down past the end of the if statement, which is going to bring us to here. All right, and if there's any more lines of code down below here, we'll continue on doing the normal execution with those lines. So the if statement checks the condition. This is the condition here in parentheses. If the condition is true, then we do the statements that are inside the curly braces, which start here and end there. If it's not true, we skip over the curly braces and we move on to the next line. So that's how a conditional statement works. All right, so to be clear, if statements will always have the following parts. They'll have the word if, that's pretty simple. It's always going to be there at the beginning, and it's going to be immediately followed by a set of parentheses. Inside of those parentheses, there has to be a Boolean expression, something that evaluates to true or false. And then after the parentheses, you're going to have an open curly brace, a block of code that you want to execute when that condition was true, and then finally a closing curly brace. All right, so that's the structure of an if statement. You're going to use them quite a bit because it turns out this is one of the more useful things for writing code, is being able to have the computer make a decision. I'm just going to move that window up a little bit. Well, I cannot move it up. Okay, well, I'm going to stop moving the window then. All right. So the next statement is, when you are writing an if statement, you're always going to want to indent the code that's between the curly braces. To be clear, the computer doesn't care that you do this. The computer will execute the code either way. This is simply to make the code more readable. So what I'm talking about is, if you notice on the screen here, these two lines that I'm drawing a red line next to, they are not at the same margin as the if statement or the closing curly brace. And that's because all of those are inside the if. We are only going to execute the two things that have the red line next to them if the if statement turns out to be true. If x is equal to y, then we're going to change x to 2 and y to 7. If x is not equal to y, then we're not going to do that. So this is to make it clear that these two statements are inside, and when I say inside, I'm referring to the fact that they're between that open curly brace and that closed curly brace. That is the code that I want to execute when this condition is true. All right. So, write a program which asks the user a math problem The problem being 7 plus 4 equals, and then we're going to tell them if they got it correct. All right, so we're going to go over to a Replit window, and the first thing we're supposed to do is to ask the user a math problem. And the math problem in particular is 7 plus 4. So we're going to print out 7 plus 4 equals, and we're doing that directly inside of a print statement. 7 plus 14. Let me get that right. Okay, so right now if I run this program, all that's going to happen is it's going to print out on the screen 7 plus 14 equals, and then it's just going to stop because there's no more code down below. So clearly that's not what I wanted. What I want is I want to read in the user's answer. And anytime I'm going to do a read statement, I need to import Java util scanner. And then I also need to create a scanner object. Sorry. All right, and now, again, none of that actually changes the functionality of the code. Now I'm able to read in an answer. So I'm going to store their answer in a variable, which I'm going to call answer. And I'm going to say int answer is equal to myscan.nextInt, because I'm reading in an integer from the user. All right, so let's run this and make sure this works and I haven't forgotten any semicolons. So what I would expect to happen is it's going to print 7 plus 14 equals, and then it's going to sit there and it's going to wait for me to type in an answer. When I type in the answer, which I'm going to type in 21, nothing happens, the program just ends. You can see this went back to run because it's completed doing what it's going to do. I'm going to make one change, which is I'm going to change this from a print line to just a print. And the only thing that changes is, if you notice where my 21 is, it's on the next line. If I change it to a print and I run this again, the 21 will actually be entered on the same line as the 7 plus 14 equals, which just seems to make more sense overall. So when I type in my 21 now, you see it's on the same line. Okay, so that allowed the user to type in an answer, but we're not really checking to make sure that what they typed in is correct. So now we need a conditional. So I'm going to say if the answer, which is the variable that stores what the user typed in, which in this case was 21, is equal to, and remember, when you're checking if two things are equal, you're going to need two equal signs. So if it's equal to 7 plus 14, which is the original question, then I'm going to print out correct. All right, so let's run it again. So now it's going to start off at the beginning. It's going to go and do line 5, which makes the scanner. It's going to print out 7 plus 14, which it just did. And then it's going to wait for me to type in an answer because of this int next, or this myscan.nextInt. So I'm going to type in 21, and I'm going to hit enter. When I hit enter, it's going to take 21 and store it in a variable called answer. Then it's going to move on to line 9, and it's going to check if 21 is equal to 7 plus 14. Since that is actually true, it's going to move on and do the line of code that's in here. So I'm going to hit enter now, and you see I get the word correct. All right, so I'm going to run this again, and this time I'm going to put in the wrong answer. So 7 plus 14, maybe it's 22. Let's see. So I type in 22, and I hit enter. And you notice that I did not get the word correct. It only does this line of code if this condition evaluates to true. So it's comparing 7 plus 14, which is 21, being equal to whatever answer was stored in the answer variable. And that's checking to make sure that it's correct. All right. So, as we said, the steps were print out the problem, read in the answer, determine if the answer is correct, and then if it is, print it out. So let's take a look here, and that's going to be similar to what I wrote. In this case, I called the variable user answer instead of just being answer. You can call it whatever you want, of course, and that's the same code where we're checking if it's correct, and there we have it. Okay, so that's how you write a very basic if statement. You're checking to see if one thing is true, and then you're doing something based upon that. In this case, I'm just printing out the word correct. What if the user gave me the wrong answer? So as the code is currently written, the program does nothing. As you saw, it just ended after I typed in 22. It doesn't say wrong, it just stopped. And that's maybe not exactly what I wanted. So how could we make it so that the program keeps track of whether I got the question right or not, and then tells me no if I got it wrong? So what we're going to do is we're going to modify the code a little bit. And what I'm going to create is I'm going to make a variable called correct. What did I call it in here, actually? Let me use the same variable name. I called it counter. All right, so I'm going to make a variable called counter, int counter, and I'm going to set it equal to 0. Now you might say, what is this? Okay, as they answer the question, if they get it correct, I'm going to add 1 to the counter. And then at the end, if the counter is still equal to 0, I know that they got the question wrong. If the counter is equal to 1, I know they got it right. You might say, well, this seems like a long way to go to get to do this, but there's an advantage to doing it this way, which is if later down the road I want to add in more questions, the counter will still work. So here's what we're going to do. If the answer is correct, then I'm going to say counter equals counter plus 1. And I certainly could have said counter plus plus. That's the same statement in there. But that adds 1 to the counter. Now, after this if statement is done, I'm going to check the counter. So if the counter is still equal to 0 at this point, then I know that they got it wrong. So at that point, I'm going to print out, you were wrong. Okay, so I'm going to run this code again, and let's see what happens this time. So I'm going to type in 21 as the answer, and we see that it says correct and life is good. Nothing has changed there. Now I'm going to run it again, but this time I'm going to type in 22. And let's talk through what's actually happening. So 22 is getting assigned to the variable answer. Counter is set to 0. So right now we have answer, which is 22, and counter is 0. If 22 is equal to 7 plus 14, which is 21, so that's false. And the way that false works is, oh goodness, I don't know what that just did. The way that works is, if this is false, it's not going to execute any of the code inside the curly braces. So it's just going to move on to line 15. At this point, it checks to see if the counter is equal to 0. Well, nothing has changed the counter because that line in the middle never happened because the condition was false. So the counter is still 0, so therefore it's going to print out you were wrong. And so we're going to hit enter, and sure enough, I see you are wrong. So now this works correctly. No matter whether I type in a correct answer or a wrong answer, I get what I'm supposed to get, which is either the word correct or the word wrong. Okay? So this is using a counter to keep track of something. And here's the final code, the same as what I just wrote on the Replit window, but just so that you have it as a reference, there it is on the slides as well. Okay, so now let's modify the previous code. So this time, instead of asking 1 question, it's going to ask 3 questions. So in addition to 7 plus 14, it's going to ask 9 plus 15 and 11 plus 34. And at the end, I'd like it to tell me how many questions that the user got right. So 7 plus 14, 9 plus 15, 11 plus 34. So what I'm going to do is we have our original print statement here where I printed out the first question. I'm going to change my variable name to answer1 instead of just being answer because I'm going to end up with 3 answers now. I'm going to leave the counter as 0, but I am going to move it a little bit. I'm just going to move it up above the first question. To be fair, it would work where it was, but I'm just going to make it up, put it up towards the top so that it makes a little bit more sense because it's not related to the first question. Okay, so I printed out 7 plus 14. I read in the answer and I checked to make sure that that one was correct. Let's go ahead and give them the second question. So system.out.print, and the next question is supposed to be 9 plus 15. All right, and I'm going to read in their answer to that one. I'm going to call this answer 2, and I'm going to store an integer into that again. I'm going to check and see if that one's right. So if answer 2 is equal to 9 plus 15, then we're going to add 1 to the counter. I'm going to do counter plus plus this time. And then I'm going to tell them that they were correct. All right. And then finally, we're going to get to the third question. So system.out.print again. And this time I'm supposed to be asking them 11 plus 34. And we're going to read in that answer, int answer 3 equals myscan.next int. Now you might ask, why am I using 3 separate variables here? Answer 1, answer 2, answer 3. Well, the 3 things are unrelated. Their answer to the first question, second, and third are all different. So it seems to make sense to have separate variables for each of them. You could do it with one variable and just check it as you go, but it's probably better to get in the habit of making 3 separate ones. So if answer 3 is equal to 11 plus 34, then we're going to counter plus plus, and we're going to print correct. All right, now at the very end, if the counter is 0, I'm going to tell them that they got it wrong, and they got all the questions wrong. Because that's what's really happening now. If the counter is still 0, they got all the questions wrong. If the counter is 3, then they got all the questions right. And then finally, I'm just going to tell them how many questions they actually got right. So I'm just going to do another print statement down here that says, you got, and then I'm going to do plus counter, correct. All right, so let's run it. We're going to do math together. First off, we're going to find an extra parenthesis that I left at the end of this line for some reason, and then we're going to try running that again. I'm just going to move that over so that you can see this. You don't need all of this space, so I'm going to move that over, and we're going to follow along. All right. I did count plus plus instead of counter. All right. Careful with your variable names. They have to be consistent. Okay, so 7 plus 14, I'm going to say that's 21. It says correct. 9 plus 15, I'm going to say that's 22, which is not right. And then it's asking me for 11 plus 34, and I'm going to say that's 45. It says correct. And then it says you got 2 correct. So what's happening here is that counter variable starts off as 0. And as I answer each one of the questions, either the counter variable gets incremented, i.e. 1 gets added to it, or it doesn't. And the if statement is what's determining that. The if statement will only add 1 to the counter if I got it correct. And so that's how you use if statements to do something kind of interesting. All right, and the solution for that, again, is in the slides just in case you want to go back and reference it. That's pretty much exactly what I just typed. All right, so that brings us to what happens if you want to tell them that they got it wrong and you don't want to let them continue once you found out that they did it wrong. Well, that's where we're going to use a new keyword that we've never seen before, and this keyword is the word return. Return actually means something more than what I'm about to explain, and you'll learn more about this in later classes. But for right now, anytime you type the word return in the middle of your method, it's simply going to stop execution of the code right there and then. So it's effectively going to end your program immediately. All right, so let's go over and play with this over here. So what I'm going to do is I'm going to, after they got the first question wrong, I'm going to go ahead and have the program stop. If answer 1 is not equal to 7 plus 14, then I'm going to say return. All right, and just before I do that return, I'm going to add in a print statement. You are wrong and we are stopping. All right, so I'm going to run the program again, and to be clear, it's going to print out 7 plus 14, that's that line of code, and then it's going to wait for me to read in an answer. I'm going to type in 22. It's going to check if 22 is equal to 7 plus 14, which it is not, so it's going to skip over this, and it's going to come down here, where it's then going to check if 22 is not equal to 7 plus 14, which that is true. Now let's just think about that for a moment. 7 plus 14 is 21, and what I typed in is 22. So the question is 22 not equal to 21? And that's true. All right? So because that's true, it's going to print out you are wrong, and then it's going to end the program. All right? Oops. So I'm going to hit enter over here, and it says you are wrong, we are stopping, and notice that the program ended. It didn't move on to the next question, it just stopped. Now, you wouldn't do this very often, but if you need a program to just stop in the middle, you can just call return. I will caution you that if you just randomly put the word return on a line, like this. So this is not inside of an if statement right here on line 21. You're actually going to get a compile error because Java's going to say, okay, on line 21, you're forcefully ending the program. But then there's code on line 23 that's telling me to do something which I'm never going to get to because that's going to always end the program. It was different up here because I might end the program, but there was a good chance I would continue on. Here, there is no chance I continue on. This is going to end the program. And because of this, you can see that there's an error here. It says on line 23, there's an error, there's an unreachable statement, meaning it's never going to get to this because of that return. So you can't just put it randomly in the middle of your code, but it is occasionally sometimes useful inside of an if statement, which is what I did there. All right, so that's what the return statement does. Again, it has other meanings, but we'll get to those later on in other classes. Here's another example of that. So what we have is, again, a scanner to allow us to read in information. And then what I'm doing is I'm saying print out, and again, it's a math question. And in this case, the math question is 2 plus 6. It reads in an answer and it stores it in answer. And then it says if the answer is not equal to 8, print out, sorry, that's incorrect, return. So that's a very similar example to what I just did. Notice that this let's continue down here will only happen if this evaluates to false. And this would evaluate to false if they gave the correct answer. So answer is 8. 8 not equal to 8 is false. 7 not equal to 8 is true. So this only continues if they did not give you the wrong answer. All right? Okay, so that's what that is saying. It is possible inside of an if statement to have more than one condition that you're checking. And this is where we would use the or, the and perhaps even the not that we talked about in the last class. So here's an example of a more complicated if statement. If letter is equal to lowercase a or letter is equal to capital A, then we would do stuff, whatever the do stuff is. This is a comment, and obviously there would be code in here telling it what to do. So remember that an or will happen if either one of these is true. And so this basically checks if they gave me a lowercase a or a capital A, then I'm going to do something. And this is useful if you wanted something that was case insensitive, where the user might not know that they had to type in a capital A. There's a couple of things I need to talk about here with regard to the formatting. So the first thing is, you'll notice that I mentioned that an if statement must always have a set of parentheses that surround it. And very specifically, the first set of parentheses are the ones that I'm just covering over there in red. And you notice that they wrap around the whole statement. They must be there no matter what. Then I have inner parentheses because I'm trying to check two different conditions, and each one of those conditions should be in its own set of parentheses usually. And so, for example, here's one, that's letter equal to A, and then here's the other one, which is letter equal to capital A. And then I'm using an OR operator in between the two of those. So it evaluates this side, then it evaluates this side, and then it does the OR between them. So to be clear, let's assume that we have a read statement up above this, and letter is equal to B. All right, so let's walk through how this is going to work. So what it's checking is B equal to A? And obviously that is false. So this gets replaced with false. Then it checks if B is equal capital A. And again, that's going to be false. So that leaves us with false or false, which is going to be false. Because an OR statement, one side has to be true in order for it to be true. If both are false, then it's false. And so this had the expected behavior. They gave me a lowercase b, and I was checking to see if they gave me an A, either lower or capital. They didn't, so therefore I'm not doing the stuff, whatever the stuff is in this case. All right, so that's a compound if statement where there's more than one thing being checked inside of your code. These are all things that people tend to want to do, and let me be clear that none of these work. Everything on this slide is bad. So the first one that people tend to want to say is, if letter equals A or A. And that logically makes sense in your head, but this is not valid code. You can't just say A or A. That does not mean anything to the computer because that's not a valid Boolean. A is not a Boolean, therefore A or A is meaningless. So this is bad. You definitely don't want to do that. The second one that's a problem is this one, and that's what I mentioned, the equal sign. It's very easy to make a mistake and put a single equals instead of a double equals. Now, the unfortunate part is that this second statement will run. Assuming that letter is of type character, what it's going to do is it's going to try to assign to the word or to the variable letter a lowercase a, and then it will try to assign it to a capital A, and since both of those worked, this will probably return true. It's always going to be possible to do an assignment. This is not checking if there's currently an A in letter. This is putting an A into letter. These are assignments because it's a single equals. This was a test. This is an assignment. Remember that. So this is bad because you're doing single equals. All right, our third one is missing the outside set of parentheses, and this won't compile without them. So there has to be one outside set of parentheses that surrounds the entire condition that you're checking. There can be multiple internal parentheses, and that's fine, but there has to at least be one outside one. And then the final one is this one. So what's wrong with this is that this is syntactically correct, except for the fact that there needs to be an extra parenthesis there. So let's go ahead and fix that while I'm talking. But even though it's syntactically correct, it's still not valid. And the reason that it's not valid is because you couldn't possibly have a character stored in letter that is a lowercase a and an uppercase A at the same time. This is checking that there's a lowercase a, and this is checking that there's an uppercase A. And the most important part of all of this is this. That's an and, not an or. Well, you can't possibly have a lowercase a and an uppercase A in letter at the same time. Only one of those could possibly be true. So this will always be false. So it's not syntactically wrong, it's just logically wrong. Because the code will compile, but it will never be true. It can't possibly have both of those things in it at the same time. All right. Moving on. All right, so sometimes we're going to use the word not. This is like the or and the and that we just saw in the previous examples, but it's not uncommon. It is a common thing that you will sometimes want to use not and state the thing that you're checking backwards, which you're going to understand when I show you what's going on here. So what's happening here is I asked the user to enter in a number between 1 and 10. I read in that number and I stored it in a variable called entered num. And what I want to do now is I want to make sure that what they actually gave me was a number between 1 and 10. So the way I wrote this, I said, if the entered number is greater than or equal to 1, and the entered number is less than or equal to 10, that would be checking to make sure that it is actually a valid number. But what I want to do is I want to print out when it is not a valid number. So the little thing that you probably missed when you looked at it is that exclamation mark right up there that I circled. Because of that exclamation mark, it's going to evaluate this in the following way. So let's assume that I type in 19. Let's assume that the entered number is 19. All right, so the way that it checks this is it says, is 19 greater than or equal to 1? And that turns out to be true. 19 is greater than or equal to 1. Great. Then it checks, is 19 less than or equal to 10? Well, that's false. All right. So now it's done the two inner parentheses. So the next set of parentheses are the ones that are here and the one that's here. Notice that there are three sets of parentheses here. So we're now going to do the middle ones, which is true and false. Well, true and false is false. So the middle parentheses return false. And that leaves us with the exclamation at the front. The way the exclamation work is not false is equal to true. Well, I can't spell true, apparently. T-R-U-E. I don't know why that... I left out a letter and I didn't know how to fix it. So it says, if true, then print out it was not between 1 and 10. And indeed, 19 is not between 1 and 10. So in this case, it checks that, and it will print out this is not between 1 and 10. This is definitely one of those slides that you may need to pause on and stare at it for a moment. This if statement is checking to see if they entered an invalid number. So it's doing a reverse check. It's checking if the number that they gave me is not greater than 1 and less than 10. And that's the way that it's written. If it's not greater than 1 and less than 10, then print out it is not between 1 and 10. Otherwise, it prints good job down at the bottom when it gets down there. All right, so again, you may need to pause on this and stare at that for just a moment and convince yourself. Try it with a couple of different numbers. On the right-hand side, there's the check for if you were checking it with the number 5, how it would look. All right, so our next problem is write a program that prompts the user to enter in their grade. Read it in as a float, and then print out the appropriate letter grade. All right, so the way that letter grades work is an 89.5 or above, you've got an A. If it's between 79.5 and 89.4999, then you got a B, and so on and so forth. So let's go ahead and start writing that over in a Replit window. So I'm going to go ahead and start a new Replit, and we're going to talk about how we would go about solving this. So the first thing is easy. It's just to read in their information, right? So I'm going to need a scanner. I'm going to print out, tell me your number grade, and then I'm going to read that in, and I'm going to store that into a float or a double. I think it tells me to store it in a float. So let's do that part first. So the first thing I need to do is I need to import scanner, and then I need to create a scanner object because I'm going to be doing reading in from the user. So same as we've done before, we're going to say import java util.scanner, and then we're going to create a new scanner object, which is going to happen with scanner myscan equals new scanner system.in. All right, so now that I have that, the next thing that I'm going to do is I'm going to tell the user what I'm expecting them to do. So I'm going to ask them, please enter your grade. And realistically, it should be between 0 and 100. Maybe a lot higher if we give you extra credit, but probably somewhere in that range. All right, so I'm going to read in their grade, and I'm going to store it in a float. So I need to create a float, and I'm going to call it number grade. All right, so float num grade is equal to myscan.next float. All right, so that's going to read in their number as a floating point number. All right, so now that I have that, I'm going to check and see if they got an A. So let's go back to the problem. If their number is greater than 89.5, greater than or equal to 89.5, then they got an A. So if num grade is greater than or equal to 89.5, you got an A. Okay, so let's run that and let's just check it with that first one before we go any further. All right, so the grade that they're entering is 90, and it says you got an A. And let's just make sure that if I give them a grade that's below an A, it doesn't say you got an A. So I'm going to give them 55. Let's hope that's not your grade. Okay, we do not get told you got an A. So life seems good there. All right, so let's talk about the second one. This is the B. So in the case of a B, their grade has to be greater than 79.5, and it has to be lower than 89.4999. So we're going to need another if statement. And this one's going to have two conditions, so I'm going to have an outer set of parentheses and an inner one. So if the num grade is greater than or equal to 79.5, and the num grade is less than 89.5, then you got a B. Now let's talk about why I need that second condition. If I didn't put this part in and it simply checked if the grade was greater than 79, if they got a 90, it would first print out you got an A, and then it would print out you got a B. So I'm going to check this with an 85. Oops. Ugh. Here we go. Sorry, I had that highlighted and I didn't realize that. So I'm going to type in 85, and it says you got a B. All right, so I'm just going to duplicate this line, and I'm going to put it into a comment so that the correct version is in here still, but then I'm going to change this just to show you what would happen if I take out that second clause. So now it's just simply saying if the grade is greater than 79.5. I'm going to run this, and I'm going to type in the number 92 as my average. What's going to happen is it's going to check this, and 92 is greater than 89.5, so it's going to print out you got an A. But then it's going to proceed, and it's going to check to see if 95 is greater than 79.5, which it is, and it's going to also say you got a B, which is not exactly what I wanted to happen, and that's why that second AND is necessary. The second AND means that it has to be within that range in order for it to actually print out you got a B. So I'm going to put it back to the way that it originally was, and I'm going to run it again, and I'm going to type in 95, and you're going to see that the first one happens, but the second one doesn't happen because the AND condition requires both sides to be true, and the second part is not true. This ends up not being true because it is not less than 89.5. So therefore, the AND condition doesn't happen because an AND only happens if both sides are true. All right? So now it's just a matter of copying and pasting this for the remaining letter grades. And so if we do that, we should be able to copy and paste and paste and paste. All right. So let's start with this one. So if it's greater than 69.5 and it is less than 79.5, you got a C. If it is greater than 59.5 and less than 69.5, you got a D. And then this last one it doesn't need to be as complicated. It just simply needs to be if the grade is less than 59.5, they got an F. I think grammatically that's supposed to be an F because reasons. All right, so let's check this and let's make sure this works. So if your average in the class was a 72, I would expect that you would have a C. Let's see. Yep, gave me a C. All right, we're going to run it again. Let's check to see that a 62.5 is a D. It is. And then let's check one that's an F. So I'm going to put in 30. And it does say F. So this seems to work. So when you're writing something like this, you have to think through the conditions. What are the possible states that this could be in? The first one I dealt with was an A, and the A and the F are actually the easy ones because there's no additional thing to check. Either it's above 89 and they got an A, or it's below 59 and they got an F. But in all the other ones, there was a middle ground that you had to make sure that it wasn't part of one of the other tests, and that's why you needed the AND condition in there. All right, so the answer to this is in the slides for you as well. And it just talks about how to go about solving it. And then here is the similar code to what I just wrote in the slides. So hopefully that's helpful. All right, so that brings us to the last thing that we're going to talk about today, which is an else statement. So all of the if statements that we've looked at so far, just check if one thing is true and then maybe do something based upon that. But there's occasionally times that you want to check if something is true. And if it is true, you want to do one thing, but if it's not true, you want to do something else. And that's where an else condition comes in. So here's an example. Int number. If the number is less than 0, then print out it was negative. Otherwise, Otherwise, print out it was positive. And that's what the else does. It's basically the otherwise. So you could have accomplished this by saying if number is less than 0, print out it's negative. If number greater than 0, print out it's positive. You'd also have to check greater than or equal to 0 because 0, I think, is considered positive. Maybe, I'm not sure about that. You'd have to decide what you want to happen there. So you could do this as two separate if statements, but this seems to make more sense. If it's less than 0, it's negative. In all other circumstances, it's positive. And I would say you need to be careful when you're writing if statements that you check all the possible conditions. For example, it would be very easy to write if number is less than 0, it was negative. If number is greater than 0, it's positive. But then this code will do nothing if they give you an actual 0. Do you want it to be 0 being positive, or do you want 0 to be negative, or do you want 0 to say something else? You need to write that out in if statements. So an else condition is used when you want to do something when the opposite is true. So number less than 0 is a Boolean. That's going to evaluate to true or false. If it's true, we're going to do this statement. If it's false, we're going to do this statement. And because a Boolean can only have two states, the else happens for all other conditions, the false statements, effectively. Remember, only one of these two things can ever happen. So if I have statement block 1 inside of the if, and I have statement block 2 inside of the else, only statement block 1 or statement block 2 will ever happen. Both of them will not happen. It is physically impossible because this either evaluates to true and you get this one, or it evaluates to false and you get that one. There is no other possibility. That's the good news about Booleans. It only will do one of the two things. All right, so if we look at the flowchart for a if-else statement, we start off with the condition, which gets evaluated. If it's true, we do statement block 1 and then we move on. If it's false, we do statement block 2 and then we move on. And so that's how that works. All right, so as an example, enter your grade for CSE 1300, reads in a grade. If the grade is greater than or equal to 59.5, print out you're passing, otherwise print out you are not passing. This is just a very simple yes or no, you are passing the class. You could certainly have written this differently. If the number grade is less than 59.5, print you are not passing. If it otherwise, print you are passing. So let's talk about the difference between these two. I'm going to flip back and forward, back and forward. You'll notice that the first two lines stay the same. The thing that's changing is this condition. In this second version, I'm checking if the grade is less than 59.5 and telling them that they are not passing. In the other one, I'm telling them that they are passing by checking if it's greater than it. So it's just a matter of whether you want to do this based on whether you want to think about it positively or negatively. In the first example, we're thinking about it positively. If the grade is greater than or equal to 59.5, you're passing. In the second one, we're thinking about it negatively. We're saying if the grade is less than 59.5, you are not passing. And please note this is less than, not less than or equal to, because 59.5 is a passing grade that would round up. So you can do this either way. And the point of these two slides, and I'm just going back and forth between the two of them again, is that both of these are equally correct. There is no one of these is better than the other in any way. They are both equally correct. It's just a matter of how you thought about doing it. And that brings us to the point that there are often many ways to write the same logic in code. You could say, if the number grade is greater than 59.5, do one thing. You could say, if it's not greater than 59.5, do something else. So you could use the not, you could use a less than or equal to instead of a greater than. You could do all kinds of different things to make this work. So there isn't one right answer. And that's a very important point. You need to think through, does your code accomplish the task? It's not, is it the best or the correct answer? It's just, does it accomplish the task? Later, after you've been developing for a while, people will ask you, is there a better answer or a more efficient answer? But that's not something we're concerned with yet. All right, so our last problem here is we're going to write a program which asks what two teams are playing in a basketball game. We're going to read in the name of each team, and then we're going to read in the current score, and we're going to tell the user which team is winning. All right, so back over to Replit, we're going to create another new Replit here. And we're going to break this down into its individual steps. So the first thing I'm supposed to do is I'm supposed to read in the name of the two teams. So I'm going to ask them for the name of each team. So I'm going to need a scanner because I'm going to be reading in information. And so I'm going to need to import a scanner like I've done before on all the other examples. And I'm going to need to create a scanner object. These are both things we've talked about pretty extensively before. I'm just going to move these over so that you can see the full screen a little bit clearer. All right, so we're going to start off and we're going to import Java util scanner. And we're going to create the scanner object. Scanner myscan equals new scanner system.in. And that's because I'm going to be reading information. All right, so the first thing I'm going to do is I'm going to tell the user what I expect for them. What is the name of team 1? Okay, so I'm going to read in that name. So I need to store that name in a variable. That variable should be a string because they're going to type in KSU, Kennesaw State University, Georgia State University, Georgia Tech, University of Georgia. They're going to type in something like that. So that's going to be a string, and we're going to call it team1 name. And I'm going to set that equal to myscan.next line because I'm reading a line of text. Next off, I'm going to ask them for the second team name. All right, and I'm going to store that one in another string, which I'm going to call team2 name. All right, so I've now read in the names of the two teams. All right, so the next thing that I'm supposed to do is I'm supposed to read in the current score. All right, so I'm going to print out, I'm also going to fix that to a T. I'm going to print out what is the score for. Now I could say team 1, but I actually know the name of team 1, so I'm going to go ahead and use it in here. Team 1 name is a variable that has the name of team 1. So if they had typed in KSU here, it's going to say, what is the score for KSU? I'm going to read that into a variable, which should be of type int, and I'm going to call it team1 score. So myscan.next line, this is an int that I'm reading in. All right, likewise, I'm going to ask them for what is the score for, this time, team 2 name, and I'm going to read that in to team 2 score. Okay, great. So I've read in the names of the two teams and the scores of the two teams. So now I'm going to use an if statement to determine who's winning. If team 1 score is greater than team 2 score, I'm going to print out team 1 is winning. And I'm going to call them by their actual name. So I'm going to say team 1 name is winning. In all other conditions, I'm going to say team 2 is winning. All right, so let's run this and let's do an example. So we're going to presume that KSU is playing Georgia. All right, so the first team name is KSU, and the second team name is Georgia, which I misspelled. Sorry about that. All right, so what is the score for KSU? Well, we're obviously at 80, and Georgia is obviously at 40. They're not doing very well. It says KSU is winning. All right, so let's run it again. And that was correct. KSU was winning. KSU had 80, Georgia had 40, so therefore KSU was winning. Let's do this one. Same teams, KSU. This time I'll spell Georgia right. And then what is the score for KSU? Let's do it the other way around. So this time KSU is at 50 and Georgia is at 60. Okay, and in this case it says Georgia is winning. All right, so it seems to work correctly. The if statement checks to make sure that this is right. If this is true, if team 1 has got a higher score than team 2, then team 1 is winning. There is one logical flaw in this code, which is, what if they're tied? As it's currently written, it will print out team 2 is winning, because it's not checking that condition. It's only checking if the score is greater than, and then the other possibility is that it's less than or it's equal to. So you might want to think about that, and in the next class we're going to talk about how you could go about solving that, because there's actually three possibilities here, which is Team 1 is winning, Team 2 is winning, and there's currently a tie. But as it currently stands, this will print out Team 2 is winning, even if there is a tie, which maybe that's not right, maybe that's not right. All right, so the code for this is in the slides, and that is the end of today's lecture. And so we're going to pick up here and do more example with conditionals next class.